Okay, am I here at number 4?
I'm not here number 4 because
No.
it's ridiculously easy.
Oh, you're being sarcastic. Okay.
No, I was
21. Okay.
He's not creative enough for this class.
18. Wait.
Whoa. Okay. Whoa.
Definitely
You're making
21.
fun of my answer.
21. Okay, let's start with 21. 21 says,
I don't need the test.
f of x is, it's on page 22, f of x equals 3x squared minus x plus 2. We're going to find a whole bunch of things. Yeah.
I don't need that part. If you want to start from fa plus 1.
But I need you to start at the
Oh,
beginning.
okay.
so-
Are you showing in this class? Can we do that? What? Are you showing in this class? The only person I ever do this with.
All right. So number 21, f of 2 means Evan just plug in 2 for the x.
Okay. Well, let's,
Okay.
I didn't even do it, and it just looked.
Okay, great.
confusing.
So 2 squared is 4, times 3 is 12. These are going to cancel, so the answer is 12, right? Yes?
Yes.
Okay.
Next one, 16.
Next one is going to be 3 times 4 plus 2 plus 2, so that's going to be 16. Okay? And then f of a is going to be the exact same thing with a's in there instead of x's. And then f of negative a, this is going to stay as 3a squared because negative a times negative a is still a squared. But this negative and this negative will cancel out and make that plus a plus 2. All right? You okay with that? All right, now the fun begins. Because now we're going to plug in not just a single term, but we're going to plug in a binomial, a plus 1. So I need to figure out what 3 times a plus 1 squared minus quantity a plus 1 plus 2 is. All right? So first step, you just write it out. And anywhere you see an x, replace it with an a plus 1. Okay? All right, you need to be able to get to a place very quickly where you can figure out what a plus 1 squared is in your head. Good job. A squared plus 2a plus 1. Okay? First thing squared, second thing squared, then multiply them together, double it. Just how that goes. The negative sign goes through both of those terms, so that becomes minus a minus 1, and then a plus 2 on the end. Okay? And then in the interest of time, I'm going to just sort of do this all in one last step. This is going to give me 3a squared. 3 times 2a will be 6a. Take away an a, leaves me with 5a. 3 times 1 is 3. Minus 1 is 2. Plus 2 is 4. So that works out to be 3a squared minus 5a plus 4.
Why was it minus 5a minus 6a minus 8?
Because it's supposed to be plus 5a and I wrote it down wrong. Okay? Alright? Okay, do you want to keep going?
Yeah.
You want me to do the other one with this? Okay, so 2 times f of a, you would just take this thing right here and multiply it by 2.
Right.
Yep, so it'd be 6a squared minus 2a plus 4. Okay, whereas f of 2a means that you need to plug 2a in there instead of x. So do you see the difference there?
No.
The first one you plug in a first and then double all of your answers. That's 2f of a, and that would be 6a squared minus 2a plus 4. F of 2a means that you plug 2a in for all the variables right off the bat. So that's going to be 3 times 4a squared minus 2a plus 2, which works out to be 12a squared minus 2a plus 2. So 2 times f of a and f of 2a are not the same thing. Okay? One is you plug it in first and then double it. The second one is you double it and then plug it in. Okay? Same dealio with f of a squared. If I plug in a squared here, then that's going to give me 3a to the 4th minus a squared plus 2. Whereas if I do f of a and then square it, I need to plug in a first, so that's 3a squared minus a plus 2, and then square my answer. Multiply that by itself. You want to do that? What's that?
I was lazy and I just.
Yeah, that's
Just do a shortcut.
that's a lot of work. So all of these by 3a squared is going to give me 9a to the 4th minus 3a to the 3rd plus 6a squared. All of these times negative a is negative 3a cubed plus a squared minus 2a. And then all of those by 2 is 6a squared minus 2a plus 4. Okay? Well, I'm sure I made a mistake in there somewhere. Combine your like terms, 9a to the 4th. This is going to be minus 6a cubed, 12a squared, 13a squared. What's that? No, those are brackets. Yeah, that's okay. And then minus 4a, and then plus 4. Okay? I don't know if is that what you got? Okay. All right, so again, same thing as this. The order matters. If you plug in a squared, that's different than if you plug in a and then square it. And then like I have alluded to a couple of times already, we really are going to have lots of fun with this a plus h thing. So this would be 3 times a plus h squared minus a plus h plus 2. Okay, there it goes. So I have to square this first. So a squared plus 2ah plus h squared. Don't forget the negative goes through both of these things. Plus 2 on the end. Right? Distribute the 3. Any simplifying we can do? Doesn't look like it, huh? Okay, so that's that. All right.
See how it is, Leanne.
So that was a nice short problem. Only took us 3 boards to do that. All right. What else?
24.
24.
What's the difference point?
Difference quotient. Evaluate the difference quotient for the given function. Gabe, this
Leanne has a
is
question.
a difference quotient.
Leanne has a
What?
question.
Can you just tell me what vertical goals?
Yeah, that's how far you are going just in the vertical direction, just in the x direction, not that. Vertical, just in the y direction. What's your question, Liam? Okay, so this kind of the same thing as before. We need to figure out what f of a plus h is. So we need to cube that. So this is going to be that cube. And then we need to figure out what f of a is. So we need to plug in a for that, which would be a cubed over 8.
Why don't we cube everything?
Why don't we cube everything? Because the h is not being plugged into the function. There's no f around it yet. So it's just plain old 8.
Yes.
And there's a reason for that, which we'll talk about later. Okay? All right, do you remember what a plus h cubed is?
Oh, yeah.
It is going to be in our little Pascal's triangle.
Oh, no, I didn't know that. That's too much.
It's going to be 1a cubed plus 3a squared h
Parentheses.
plus 3ah squared plus 1h cubed. Okay?
Yep.
So if you're just doing a simple binomial like that where both of the things are variables, it's really easy to use the, use Pascal's triangle to figure out what that is. Okay, what? They're both triangles, they both start with P. And then I have minus a cubed over h. So a cubeds cancel. Yeah? Okay, now with what's left, everything has a everything has an h in it, so I can make that be gone. I can make that just be to the first, and I can make that squared. So my final answer is 3a squared plus 3ah plus h squared. All right? Perfecto. Está muy bien. Okay, what else? 28?
Just get holes, like exponential
What was the answer now?
Yo no sé. All right, 28, we're looking at domain. And so we can't, you guys are chatting today.
I'm learning a new system.
Okay, we can't divide by 0, right? Yep, so we're going to factor the bottom into
X plus 1 plus 2.
x plus 1, x plus 2. So if I set that equal to 0, that would mean x would equal negative 1 and negative 2. So that means it can't be those things. So my domain is going to be negative infinity to negative 2, negative 2 to negative 1, and negative 1.
Why couldn't you just like do negative infinity to negative 2, negative 1 to infinity?
Because then you're missing out on all the numbers in between negative 1 and negative 2 that the function could be. Okay? Yeah, what have you got against those things? If you look at the graph, what was the original thingy? X plus 4 over x squared. Right, that's what we're talking about right now, Mary. That's what we're talking about right now. Why do you need that middle part? Okay, if you look at the graph of the function, that tells you what the domain is also. So this is the piece that goes from negative infinity to negative 2, right? But then there's also a piece that goes from, it's this little guy right here, negative 2 to negative 1. And the graph does take on values there, so you need to include that. And then it goes from, from negative 2 to negative 1, that's in here somewhere. Okay? So those things, those values of x, you can plug those in and get an answer for y. So they're in the domain.
Well, what I'm saying is, why do you have this whole space between negative 1? Well, because you can use
Because you can use those numbers. If you just go negative infinity to negative 2, and then negative 1 to infinity, you're leaving out, there's that.
Oh,
Right.
no, I gotcha.
Okay? There's that gap there that you need to include. All right, what else? 51. Now we're getting into the fun stuff. Find a formula for the described function. Okay, a rectangle has a perimeter of 20 meters.
Oh, I was looking at the wrong one. I was looking at 52.
So, okay. A rectangle has a perimeter of 20 meters. Express the area of the rectangle as a function of the length of one of its sides. So we'll call this length, and we'll call this width. Right?
Well, yeah, but it is L plus.
Why did you do that?
Why is that confusing? Are you teasing me?
Length times width equals area.
Okay, so the area is equal to the length times the width. Okay? But then we also know something about the perimeter. What's the perimeter?
2 times length
2
plus
times the length plus 2 times the width. Okay?
20 equals 30. Oh, it's not close.
Yeah? Alright, and then they told us the perimeter is 20.
Yeah, but I read 2.
Right, so we can plug that in for the perimeter, divide everything by 2, and find out that the length plus the width has to equal 10. Or in other words, we're going to solve that for the length of the width. Width, okay, the width is equal to 10 minus the length. So now that we, then plug that in over here, so the area is the length times 10 minus the length, but you can leave it like that, or you can write it as 10L minus L squared, either one of these is fine. Okay? So that's that game there, and I screwed this up when we were doing that problem on Friday with the open top container. I thought we were going to have to use 2 variables, and we found that now that we do the volume of the container or something like that. No memory? Okay. So we were able to solve.
I remember the problem.
Okay. So we're able to solve that for H and plug it in. So you want to always use as few variables as you can. Yeah.
Because I did L like length plus X kind of thing for the other part. I thought something cool might happen.
Oh, okay. All right, anything else?
57.
Is that my learning target?
No, that's advanced algebra. I'll put these up in a second. What? 57?
Yeah. I wish I was on.
Okay, so we're back in open top box land with number 57. The what?
The odd even or
Yeah.
I just forgot.
Okay. Yeah, we'll do that in a second. All right, a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 12 inches by 20 inches by cutting out equal squares from the side. If I had $1 for every time I've done this problem, I would have more than $1.
Wow.
Yeah. I know, right? This problem just comes up in geometry, you do it in algebra, you do it in pre-calc,
Yeah, and every time I do it, I never learn how to do it.
and every time you do it, you still never know. Okay, so we're going to cut out squares from each corner, and then fold the flaps up, and then we have a box, right? So our original piece of paper was 20 by 12, so this is 20 all the way from there to there, and this is 12. Okay? All right, what are we trying to do? Express the volume of the box as a function of x. All right, so volume of a box is the easiest one. It's the length times the width times the height. What is the length of this box? 12 minus 2x, because I cut out an x here and I cut out an x here. So that is 12 minus 2x. What is the width? Same thing, except now we're starting with the side of 20 and then cutting out 2 little pieces from there. Okay? And then what is the height of the box going to be when you fold those tabs up? Good, x. Got that? All right, so then did you foil this out or just leave it like that? You foiled it, just says,
Looks good the way it is.
looks good the way it is. If you foiled it, you would get 240
Yeah, like,
minus, that's going to be 40x minus another 24x is minus 64x, and then plus 4x squared, but then when we run that x through there, it's going to be x squared, and x if you go to the U next year and you take calculus or math class or whatever, they do it all the homework on computers now. You just type in your answer in the computer, and the computer tells you whether you're right or not. And this answer and this answer are exactly the same because the way the computer tests whether your answer is right is it plugs in a number for x, and as long as it gets the right answer, then you're correct. So you don't have to do all that single time stuff. Just saying. Okay, what else?
and there's just
61? Oh, this is that odd even.
I ran out of paper at home, so.
What did you just say, Evan?
I said I ran out of paper at home. What do you think I said?
That's what I thought you said.
Okay.
How early did you run out of paper?
At my house.
Oh.
I didn't bring any paper home.
Okay, 61, say whether they're odd, even, or neither. So we talked about on Friday, I think it was, that if you plug in f of a and you plug in f of negative a and you get the same answer, what's true about the graphs?
Is
Then those would be even. And if you take and plug in f of a and then you plug in f of negative a and you get the opposite answer, then that means that your graph is odd, okay? So one of the things that we did not talk about is how that looks graphically. So let's say with this yellow one right here, that this is that's negative a, and this over here is a. If I go up to the yellow graph at negative a, and I go up to the graph at positive a, what do you notice is true about the y values? They're the same. So in the case of the yellow graph, f of a equals f of negative a, so that means that, which function was that? G is an even function, okay? And so one of the things you could add to your notes is that even functions are symmetric with respect to the y-axis, okay? All right, now if I take this right here, if I plug in f of a into the green graph, I get this answer. And if I plug negative a into that, I get this answer. So this is the same as that, but one is positive and one is negative. And so that means that this function right here is odd, okay? And what is this symmetry here? Not the x-axis, because the top and the bottom, if I flip that up, I get a different graph. Around the origin, very good. So that means that if I take any point on this graph, if I take this point right here and I go straight at the origin, and then I go the same distance through the other side, I'm going to end up on the graph again, okay? So that is a characteristic of odd functions. Anything else? Okay, turn them in then, would you? For graphing calculators, is there anyone who does not have one? You left one at whose house?
It says it's not on his room, I know it is.
it's really good place.
Who, you don't have one at all?
I
What's that?
have one, I just keep forgetting.
Okay.
I think mine needs an update.
I'd say that.
I want the color.
Yeah, because you're doing that.
Oh, no. Why is no one looking at me? Oh my god. It's like a fun, it's like, I feel like a play on words.
My batteries died over the summer. All right, so the very first thing that they wanted us to do was to graph the function. I graphed it. What is it? X squared plus 3, thanks. So x squared plus 3, and we're just checking to make sure you know how to change your viewing window, because a lot of times the default one that you end up with is not the one that's going to be helpful for you. Does everyone know how to get back to this window, the negative 10 by 10? You go zoom 6, and that'll give you the standard window. So that's always a good starting place, okay? Then in this one, they would like you to change it to be a negative 2 by 2 in both directions. So you hit the window button up here. You change your x minimum to negative 2, your x maximum to 2. Enter y minimum to negative 2, y maximum to 2. And now when you hit graph, you see a very different view of the same function. Okay? Really, really helpful. All right, then it says change it to negative 4 to 4 in both ways. So -4 and 4, and then -4 and 4, and then you hit graph, and now we can see just a little bit of it, okay? The most common error that students make when they're messing with their windows like that is you forget to put a negative in there. You make that be plain old 4, and then you hit graph, and it gives you, you can't do that, okay? The minimum has to be smaller than the maximum for that to work, okay? Sometimes kids get it switched around too, okay? You can do this or you can not do this, it's up to you. -10 by 10 is the next thing they wanted. That's the standard one, yeah, but then they want the y's to be -5 by 30. Okay, so just so you're familiar with the notation, the first two numbers in brackets is the x range, and then the second two numbers in brackets is the y range. -10 to 10 on the x's and -5 to 30 on the y's. If you don't like this cluttering here, that's what that scale thing is for. So I could go back here and I could say, well, if I'm going all the way from -5 to 30, instead of my y's going by 1s, I would like my y's to go by 2s. So then that line is spread out a little bit more. That's up to you. That becomes more useful if you're doing something like the last one, -5 to 50, or, and then also, I mean, -100 to 1,000. So in this case now, if you leave it as a scale of 1, you can't distinguish at all the markings on the x and y axes. And so you might want to say, okay, if I'm going from -50 to 50, that's 100, so maybe I'll go by 5s. And then this one I might end up going by, I don't know, 10s. You can mess with that, or that wouldn't help at all. 50s. There you go. And then you can see, yeah, and Jefferson's back there laughing at us because
Just on the fancy calculator, my pen that actually did use a big difference.
it did. Oh, you can see you have
Yeah,
more.
like there's actually like real lines.
Pixel
So you got better resolution than us, okay? All right, so is everybody comfortable with changing the viewing window on your graphing calculator? All right, so do that now. Take this graph here, square root of 8 minus 2x squared, that's all underneath the square root, and give me a nice viewing window that you would want to use to look at that. Oh, show. Tell me what it looks like. Like a dome?
My brother watches that.
It looks like such a dumb
It's based on what Steve is doing.
Can you watch it?
Just like farmers
I heard it looks like it.
around society.
I heard it looks like acid. I really like it.
Need more cowbell.
There we go.
No, it's not.
They just copied the Simpsons.
Okay, so if I try and graph square root of 8 minus 2x squared with the crazy window that we had before, you can see nothing. So like I said, it's usually a good idea to go back to where things started, -10 to 10.
How did you shortcut that?
You might want to, zoom 6. You might look at this and say, okay, it looks like my domain is about from -2 to 2 of the x's, so I don't really need all this other junk here. The y's, there's no negatives, and then that goes up around 3. So if you really want a good look, you might change the x minimum to -3 and the x maximum to 3. And then you can make the y minimum be maybe -1, and then go up to 4, and then take a look at that graph, and then that gives you an even better view of what's going on, okay? You can't really tell this because our scales are different, but this is actually a perfect semicircle. It's a perfectly semicircular graph.
I
Okay?
think this goes to
It looks great. Oh yeah, I have my scale for looks great. Okay, so this actually goes all the way down and touches the x-axis. Yours might be able to show that. Mine doesn't have the resolution to be able to do that. Okay. Jefferson's probably automatically comes up labeled semicircles. Tells you the area underneath it. All right, so let's try this one. Graph the function y cubed minus 150x. And again, find a way to see the graph. Oh, and if you have a calculator where when you hit this exponent button, it doesn't go to superscript, you have an old operating system and we can update that so that you have some handier features. Okay, so just give me your calculator when it's assignment time and I can do that for you. Okay. All right, did anybody find it?
I found this. I found two.
Okay, so if you start at the 10 by 10 viewing window, you got nothing. If you want to, you can use this zoom out feature. So you can hit the zoom button and then you can hit number 3 and try and zoom out. And then you can kind of, oh, well, there it is. So that might give you a sense of what you're shooting for. What do you use, Mary?
-25 to 25, and then -1,000 to 1,000.
Okay, -25 to 25, and then -1,000 to 1,000. Is that pretty now? There you go. Very nicely done, Mary. And then now you can see the whole entire thing. Okay. So sometimes you just have to work around with it a little bit. All right. Now sometimes this book is wrong because the technology is moving faster than the publishers, and so what it says is going to happen doesn't actually happen. But we will give it a try and see. So start by graphing the sine of 50x. And any time you are graphing a trigonometric function, you have to be in radians or you're not going to get the correct graph.
I know, yesterday I did stuff.
Well, that's fine.
Just like doing all that fancy stuff.
Hit the mode button
Right now.
and then scroll down. There you got it. Okay, yeah, so this has got some crazy stuff going on here. You should recall from your study last year, what is the amplitude of this function? 1. So it's going to bounce between -1 and 1. So when you graph this, you can change your y's so that they are maybe -1.5 to +1.5, and you're going to be okay. So if I go window, I'm going to leave those alone, and go -1.5 to 1.5. Okay, yeah, we'll change the x scale too. Okay, so now I've got this thing going on right here. Okay, and so you might think, yeah, that's what the graph is doing. That's an acceptable viewing window, right? Let's change our x's to -12 to 12 and see what that looks like. If I go -12 to 12, I get myself a nice trig function that you're comfortable with. You say, yep, that looks good. That's probably going to be right. But now what I'm going to do is I'm going to change the x's from -10 to 10. Okay? And let's see if the book is correct in predicting what the calculator will do. Okay, no, that didn't
Alright,
really
mine
change
looks like
it
this.
at all.
Mine did.
Yeah, that's what I want. So my
Yeah.
calculator is too old.
Wait, what did you
Yours should come up with something wacky like this. Okay, where it's got, yeah, or something weird like that, okay? And so, who said some viewing windows are more, what did you say, where, oh, graphing calculators can give misleading answers. So this is a misleading answer to this graph right now. This is incorrect, because this makes me think that in between negative 12 and 12, there are 1, 2, maybe 2.5 cycles of the graph. But when you guys look at your calculators, there's tons of them in there, right? And if you change this to, it says from negative 9 to 9, even more fun things happen. And my calculator won't do anything, it appears. I get the same wrong answer.
Oh, that
but
is
then,
fun.
yeah, you get even different sort of thing going on there, okay? Yeah, so we're both done. So you need to always think about what's going on when you graph something. How do you find the period of a function? You guys are all able to say that the amplitude was 1. How do you find what the period of this graph is? What's that? 2 pi over 50, okay? And so that means the period of this function is pi over 25, which is a very small decimal number, okay? So that means that that's why you're getting all of those things in there, because there should be a lot of up and downs. There should be a lot of complete cycles of the graph in between them, okay? So you have to be a little bit careful with that. Especially with trig functions, they do weird things. All right, play again. Graph that one.
It's a spiral. of-
Yeah, those were not parametric. Those were polar coordinates. When we did that. Dogs are barking all day. Yeah, well, I'm in this room all day. I'm not
Too close the window. Yeah, it was those. I don't know what I was wearing anything. Sweatshirt. It's supposed to be ridiculously warm.
Okay, so sine of x 0.01 cosine of x. So if we go sine of x plus 0.01 cosine of 100.
Okay, I think I did it.
All right, and now if I look at the graph, now I have a bad viewing window. I'm going to go negative 6.5 to 6.5. Why is that? Did I type something wrong?
Isn't it like
Sine of x plus 0.01
Sine of x.
plus 0.01 cosine of
That's what I.
Mine, no.
Does yours look like that?
Mine looks like
Looks like
mine
it
looks
does.
like
Mine is like
actually mine looks like
it is like a fluorescent.
That never happened. That's why my other thing wasn't going either. I was in degrees the whole time. Okay, so you have this, right? So you have this graph, right?
Yes.
And you think, okay, if I was going to sketch that, it's a nice smooth cosine function, or a sine cosine, it's a composition. Okay, but they say change it to 0.1 each way. So go negative 0.1 to 0.1, and then go negative 0.1 to 0.1. And then, so now we're really zoomed in. And then what you can see is if you really zoom in, it's not a nice smooth trig function. Each one, the lines, graph is squiggling within the squiggle. Okay, yeah, who knew? Alright. So that's the wacky things going on there too. Alright, you guys kind of get the idea here. We've got this going. I don't think you need to do this one. Well, let's just check to make sure. 1 over 1 minus x. I can't remember if mine connects the dots or not. First of all, make sure you go 1 divided by parentheses 1 minus x. And then we can make the, no, I'm going to zoom 6. Okay, so here's, all right. So the old calculators used to connect this to here. Do any of yours connect those? Okay, you don't want that. Because this is, 1 is not in the domain. There's a gap in the graph there that should show that, okay? Try cube root of x. Do you know where cube root is? It's in the math menu, and it is the 4th one down. So if you graph the cube root of x, you can take the cube root of a negative number, right? Okay, so make sure that when you do your graph, you get both this branch here and this branch here. If you only get a branch in the first quadrant, then again, you're not very cool. Okay? All right, now let's do one last one, and that is using these to solve the equation. So let's solve this equation right here. Let's solve the equation cosine of x equals x, okay? If it says exact answer, then we can't do this on the calculator. Then we have to do the whole triangle thing and figure out that whole, deal there. But if it says correct to do that 2 decimal places, that means we can estimate, so we're good to go. So if you have not done this before, we're going to graph the cosine of x, and we're going to graph x, and then we're going to put those on the big board here. And what we are trying to do is we are trying to find where those 2 graphs intersect. Okay? Do not use the trace function on your calculator to do that. That is inaccurate. Okay? All right, you want to go second trace and choose the 5th option, intersect. Now the calculator is really dumb. It knows that you're trying to find the intersection point of 2 graphs, but it's too stupid to figure out which 2 those are, okay? Because it can graph up to 10 at the same time, okay? So what it's asking you is it's saying, is this the first curve that you want to use? Yeah. So you hit enter. Is this the other curve that you want to use? Yeah, those are the only 2 there. So then you hit enter. And then for a guess, you just move the cursor close to where those intersect. There's only one intersection point for this, so you don't even really need to do that. Hit enter and correct the 2 decimal places. The solution would be 0.74, comma 0.74.
What was the second question?
Just x. Plain old x. I'll look at you. Yours needs to be updated.
Mine is 2.
Okay, we'll do that in a second. Is that assignment okay for you? On Friday?
No, it was terrible.
It was terrible?
Oh yeah, I'm game night.
I didn't have to make a tower.
I hope so.
Actually, my name could be tower.
Yes, I wish I could take the lowest grade I could possibly get on that.
We didn't, yeah, we didn't.
But yeah,
You-
one picture away.
Trish is under